The rhythmic pulse of diesel machinery echoed through Rabaul harbour as darkness settled over the water on an October evening in 1943. Standing on the command deck, the Japanese captain surveyed the formation taking shape before him. 8 additional cargo vessels manoeuvred into position, each sitting deep in the harbour waters under the weight of their critical cargo. The holds contained munitions, grain stores, medical provisions, and 2,000 ground troops destined for operations in Bougainville. These ships would navigate the narrow waterway, threading between the Solomon Islands during the night hours, a route that had become essential for maintaining contact with distant military installations. The captain possessed considerable experience with this passage, having completed it 17 times previously. The dangers were well understood. American undersea craft patrolled these depths regularly. Enemy aircraft launched strikes when daylight permitted. Yet the most persistent irritant, something that provoked annoyance more than genuine fear, consisted of the small American torpedo craft. These compact vessels had begun appearing throughout the Solomon region earlier that year, launching from concealed positions scattered along the coastline. Intelligence reports indicated they could achieve speeds exceeding 40 knots. They carried torpedo weapons, though none had yet scored meaningful hits against his vessels. These American patrol boats seemed to favor generating commotion, discharging machine guns from excessive distances, then withdrawing before Japanese escort destroyers could close the range. They functioned as nuisances, insects that disrupted shipping formations, forced evasive maneuvers, and consumed ammunition stores. Yet they failed to sink significant vessels, not the crucial transport ships maintaining Japan's southern defensive perimeter. The captain's assessment derived not from personal pride, but from established doctrine built upon accumulated operational experience and supported by intelligence assessments he had studied. The Imperial Navy had conducted thorough analysis of these American torpedo craft. They measured 77 feet in length, constructed from plywood sheets over wooden framework. Fully loaded, they displaced 33 tons. The construction philosophy emphasized velocity over durability in absurd fashion. A single round from a destroyer's 5-inch cannon would obliterate such a craft. Even sustained machine gun fire could perforate the wooden construction. The vessels carried 4 torpedo weapons, yet launching them during night operations against moving targets required approaching within 1,000 yards. This necessitated penetrating the destroyer screen protecting every convoy formation. It meant exposing themselves to searchlight illumination and concentrated fire from multiple warships. The mathematics favored the defenders overwhelmingly. Japanese convoy protocols had evolved through 2 years of combat operations in these waters. Every transport group traveled with at least 2 destroyer escorts, sometimes additional vessels. The destroyers maintained speeds of 35 knots, nearly matching the torpedo boat velocity. They carried depth charges for submarine threats, anti-aircraft weapons for aerial attack, and 5-inch main batteries capable of firing illumination shells to eliminate darkness advantage. When torpedo boats approached, the destroyers would illuminate them completely and engage with all available weapons. The Americans would discharge torpedoes from extreme distances, typically missing their targets, then retreat at maximum speed. The convoy would alter course and continue operations. This pattern had repeated dozens of times throughout the Solomon Islands campaign. It had become standard procedure. The Imperial Navy's evaluation of torpedo boat effectiveness appeared in intelligence summaries distributed to convoy commanders. The boats had achieved certain successes undoubtedly. They had damaged some barges, destroyed minor craft. Yet against major warships and transport vessels, their record remained poor. The torpedoes they employed, Mark 8 models manufactured at American facilities in Newport, Rhode Island, suffered from documented reliability problems. They ran deeper than their configured depth settings. Their magnetic detonation mechanisms frequently malfunctioned. Even direct strikes sometimes failed to produce explosions. American submarine commanders had filed complaints about these torpedo failures for 2 years. The patrol boats used identical weapons. Why should their results differ? The American commander stood in the confined control position of his patrol boat, studying the dark water ahead through optical instruments. The time approached just past midnight on October 12th. His vessel and 3 companion boats from the motor torpedo squadron were proceeding north at 30 knots, their muffled engines barely audible above wind and spray sounds. They had received intelligence from coast watchers, Australian observers concealed on Japanese-controlled islands, who transmitted ship movements via radio. A major convoy was descending from Rabaul. 9 transports, 2 destroyers. The division had been positioned at their forward base at Lambu Cove on Vela La Vela, awaiting precisely this opportunity. The patrol boats carried dull black paint, rendering them nearly invisible against dark water. The commander had ordered all reflective materials covered or removed. His crew of 12 wore dark clothing. They had practiced this approach methodology for weeks, learning to navigate by starlight and instinct, maintaining radio silence until the final possible moment. The tactics represented recent developments, refined through painful trial and error across months of combat operations. Early torpedo boat attacks had been chaotic, boats charging forward at high speed with searchlights blazing and weapons firing. They had accomplished little beyond attracting massive return fire. Crews had perished, boats had been destroyed. The Japanese convoys had continued moving. Yet American commanders had learned valuable lessons. They learned to approach slowly, utilizing single-engine operation to minimize wake and noise. They learned to attack from multiple directions simultaneously, dividing the destroyer's attention. They learned to wait for the optimal moment when range closed to 500 yards or less. At that distance, a torpedo would reach its target in under 1 minute, too rapid for convoy evasive action. Most importantly, they had learned about their torpedo weapons. The Mark 8 had problems certainly, yet some of those problems could be mitigated. Setting the torpedoes to run at 6 feet instead of their designed depth of 10 feet reduced the tendency to run deep. Disabling the magnetic detonation device and relying solely on contact detonation increased reliability. The torpedoes became weapons that functioned more often than they failed. The commander spotted the convoy at 1:15 in the morning. The destroyers led the formation, their silhouettes visible against the slightly lighter horizon. Behind them, the transports steamed in 2 columns. The Japanese maintained 15 knots, a standard cruising speed balancing fuel consumption, with the necessity to reach Bougainville before dawn. The commander signaled the other boats using a shielded flashlight. 3 companion vessels acknowledged. They spread out, moving into attack positions on both flanks of the convoy. The Japanese destroyers maintained their patrol pattern, searching the darkness ahead and to the sides. Yet they were not looking behind them, back along the convoy's wake, where 4 black shapes were closing the distance. At 1:30, the commander gave the order. His boat increased speed, angling toward the rear transport on the port side. The bow lifted as the engines opened fully, throwing spray across the control position. The commander could see the transport clearly now, a 7,000-ton cargo ship silhouetted against the stars. The range closed quickly. 800 yards, 700, 600. The transport showed no signs of alarm. No searchlights, no course changes. They had not been detected. At 500 yards, the commander ordered the first 2 tubes fired. The torpedoes launched with compressed air, splashing into the water and accelerating toward the target. Their weightless electric motors left almost no visible trail. The commander turned the boat hard to starboard, pointing at the next ship in line, 2 more torpedoes away. Then his boat was racing parallel to the convoy, having fired all 4 weapons in less than 40 seconds. The first torpedo struck the cargo ship below the waterline forward of the bridge. The explosion was massive, a geyser of water and debris shooting 100 feet into the air. The ship shuddered and began listing immediately to port. Before anyone on the Japanese bridge could react, the second torpedo hit amidships directly into the cargo holds, where ammunition was stored. The secondary explosion was catastrophic. The entire center section of the ship disappeared in a ball of fire. The bow and stern sections began sinking separately, the ship literally broken in half. The Japanese captain felt the shockwave through his vessel's hull before he heard the explosion. He ran to the port side bridge wing and saw the cargo ship burning, both sections already settling into the water. Men were jumping from the decks, silhouettes against the flames. Then came more explosions. The transport ahead of him erupted in fire as torpedoes from another patrol boat found their mark. The destroyer was turning, searchlights sweeping the darkness, yet the patrol boats were already gone, racing away at 40+ knots before the destroyers could bring them to action. In 15 minutes, 4 transports were sinking. A 5th was dead in the water, taking water from a single torpedo hit that had flooded her engine room. The survivors, including the captain's vessel, scattered in different directions, abandoning formation discipline. The destroyers pursued phantom contacts, firing at shadows. By 2 in the morning, it was over. More than 1,500 soldiers were in the water. Supplies worth months of production were on the ocean floor. The convoy had been destroyed not by submarines, not by aircraft, but by 4 small plywood boats that Japanese doctrine said were ineffective. The attack on October 12th was not an isolated incident. It was the beginning of a systematic campaign. The motor torpedo boat squadron, operating from forward bases throughout the Solomons, struck convoy after convoy through the remainder of that year. On November 2nd, patrol boats sank 3 transports off Bougainville. On November 26th, they destroyed 2 more and damaged a cruiser. The Japanese could not stop them. Destroyers could not catch them. Air patrols could not find them at night. The patrol boats operated in darkness, struck with precision, and disappeared before effective counterattack was possible. Japanese naval intelligence revised its assessment of patrol boat effectiveness by December. The boats were no longer classified as a nuisance. They were designated a primary threat to convoy operations. New tactics were developed. Convoys began traveling in daylight when air cover was available, despite increased vulnerability to Allied aircraft. Routes were changed. Extra destroyers were assigned. None of it worked consistently. The patrol boats adapted faster than Japanese doctrine could counter them. By early 1944, some Japanese commanders refused to sail without overwhelming escort forces. Others requested postponement of critical supply runs. The psychological impact of patrol boat operations exceeded their material damage. They had broken something fundamental in the Japanese convoy system: confidence. The American commander and his crews did not celebrate their victories. They had seen the men in the water, heard their screams. They understood they were drowning soldiers who would never threaten Allied positions, yet they were still men dying in the dark. The cost of this effectiveness was measured in nightmares, in the memory of burning ships, and the knowledge that modern warfare had no room for mercy or hesitation. The patrol boat crews continued their missions through 1944 and into 1945, striking at Japan's maritime supply lines until the enemy had nothing left to convoy. The patrol torpedo boat that destroyed the cargo ship on October 12th was designated with a specific hull number. Understanding why this wooden vessel succeeded where Japanese doctrine predicted failure requires examining exactly what these boats were and how American crews learned to use them effectively. The Electric Launch Company of Bayonne, New Jersey, had been building small craft since 1892. Their patrol boat design emerged from competitive trials held in 1941 when the Navy tested prototypes from multiple manufacturers. This design won based on seaworthiness and speed. The company's factory began mass production in early 1942, eventually building 326 patrol boats before the war ended. The boats measured 77 feet in length with a beam of 19 feet 8 inches. The hull was constructed of 2 layers of 1-inch mahogany planking laid diagonally with a layer of glued canvas between them for waterproofing. Frames were white oak. The entire hull weighed less than 5 tons empty. This construction was neither accident nor economy. Wood was chosen deliberately because it was non-magnetic, making the boats invisible to magnetic mines and difficult to detect with magnetic anomaly equipment. Plywood and planking could be repaired quickly at forward bases using basic carpentry tools. Battle damage that would cripple a steel vessel could be patched in hours on a patrol boat. The engines were 3 Packard Marine engines, 12-cylinder gasoline motors that produced 1,500 horsepower each. These were modified versions originally derived from aircraft engine designs. Total horsepower was 4,500, driving 3 propeller shafts. At full throttle, these boats could reach 43 knots in calm water, though combat speed with a full weapons load was typically 38 to 40 knots. The fuel capacity was 3,000 gallons, giving a range of approximately 500 nautical miles at cruising speed, or about 200 miles at full combat power. Armament consisted of 4 Mark 8 torpedoes carried in launching tubes mounted on the deck. These torpedoes were 21 inches in diameter, weighed 3,000 pounds each, and carried a warhead containing 643 pounds of TNT. They were designed to run at 46 knots for 4,000 yards, though actual performance varied. The boats also carried multiple machine guns, twin 50 caliber Browning weapons and a turret forward, another 50 caliber on a flexible mount aft, and typically several 30 caliber machine guns or 20 millimeter cannons depending on crew, preference and availability. The crew consisted of 12 to 14 men depending on configuration. The commanding officer, typically a lieutenant or junior lieutenant, commanded from the cockpit. The executive officer assisted with navigation and tactical decisions. The quartermaster steered the boat. The engine men, usually 3 men, managed the temperamental Packard engines below deck. The torpedo man prepared and launched weapons. Gunners manned the machine guns. A radio operator handled communications. Everyone aboard had multiple duties because in combat, men were wounded or killed and others had to take over their positions instantly. The American commander on the night of October 12th was 28 years old. He had graduated from the Naval Academy at Annapolis in 1938, served on destroyers for 3 years, then volunteered for patrol boat duty in early 1942. His training at the Motor Torpedo Boat Squadron Training Center in Melville, Rhode Island lasted 12 weeks. The curriculum covered boat handling, navigation, torpedo tactics, engineering, gunnery, and damage control. Yet nothing in that training prepared crews for the specific conditions they would face in the Solomon Islands. The reality of combat operations in the South Pacific bore little resemblance to training exercises in Narragansett Bay. The climate was brutal, with constant heat and humidity that rotted wood, corroded metal, and bred tropical diseases. Forward bases were primitive, often nothing more than concealed coves with fuel drums hidden under camouflage netting. There were no dry docks, no machine shops, no steady supply of spare parts. Crews learned to improvise repairs using whatever materials they could scavenge. They learned to navigate by dead reckoning because magnetic compasses were unreliable near the boat's engines and electrical systems. They learned to identify Japanese ship silhouettes in darkness from hundreds of yards away, because misidentification meant wasting torpedoes on low-value targets. Most critically, they learned their weapons' limitations through bitter experience. Early patrol boat attacks in the Solomons had been disastrous. In August 1942, 15 patrol boats attacked a Japanese convoy near Guadalcanal. They fired 30 torpedoes. Not a single one struck a target. Some torpedoes ran under their targets without exploding. Others ran in circles. Several simply sank after launch. The Japanese convoy continued unmolested while patrol boats retreated, having accomplished nothing except alerting the enemy to their presence. The transformation of patrol boat tactics began with the lieutenant commander's report filed in September 1942 after his boat fired 4 torpedoes at a Japanese destroyer from 800 yards. All 4 missed, though his navigation and attack geometry had been perfect. He requested permission to test fire torpedoes and examine their performance personally, rather than relying on ordnance specifications. Permission was granted. What he discovered changed everything. The Mark 8 torpedo had been designed in the 1920s and manufactured at naval facilities. The weapon specifications called for a running depth of 10 feet, making it effective against the submerged hulls of warships. Yet actual performance testing revealed the torpedoes consistently ran 3 to 5 feet deeper than their set depth. A torpedo set for 10 feet actually ran at 13 to 15 feet. For patrol boats attacking cargo ships with shallow drafts, this meant torpedoes passed harmlessly under their targets without making contact. Testing also revealed problems with the Mark 6 magnetic exploder, a device meant to detonate the warhead when it sensed a ship's magnetic field. The exploder was sophisticated in theory, but unreliable in practice. Temperature variations in tropical waters affected its sensitivity. The Earth's magnetic field varied by latitude, and the exploders had been calibrated for North Atlantic conditions, not the South Pacific. Ships constructed with minimal steel in their hulls, like Japanese transports built partially from wood, generated weaker magnetic signatures than the exploders could reliably detect. The squadron adopted new procedures based on these findings. Torpedoes would be set to run at 6 feet depth, not 10. This meant they would actually run at 9 to 11 feet, shallow enough to strike most transport and cargo vessels. The magnetic exploders would be disabled entirely. Torpedoes would rely solely on contact detonation, requiring a direct hit, but ensuring the warhead actually exploded. These modifications were unauthorized, technically violations of ordnance regulations. The commanders did not request permission. They simply made the changes and documented the results. The results spoke for themselves. Between October and December 1943, the squadron fired 86 torpedoes at Japanese vessels. 42 struck their targets, a hit rate of nearly 50%. This was revolutionary. Submarine commanders were celebrating 10% hit rates. The difference was range and approach. Patrol boats attacked from 500 yards or less, sometimes as close as 300 yards. At that distance, torpedo travel time was under a minute. Ships had no time to evade. The torpedoes reached their targets before lookouts could even shout warnings. Japanese convoy commanders realized they faced a new threat, on the night of November 2nd, 1943. A convoy of 5 transports and 3 destroyers was making the run from Rabaul, carrying reinforcements for Japanese positions in northern Bougainville. The convoy commander aboard the lead destroyer had reviewed reports of patrol boat attacks. He had ordered zigzag patterns, random course changes every 3 minutes designed to throw off torpedo aiming. He had positioned his destroyers in a screen around the transports with overlapping fields of fire. He had instructed all vessels to maintain maximum alert, with searchlight crews standing by and gun crews at battle stations. At 20 minutes before 2 in the morning, 8 patrol boats from the squadron attacked simultaneously from 4 directions. They had divided into pairs, approaching from port, starboard, ahead, and astern of the convoy. The convoy commander's destroyers detected the approaching boats and opened fire with their 5-inch guns. Star shells burst overhead, illuminating the ocean in harsh white light. The patrol boats were visible, racing across the water at full speed. The destroyer's fire was accurate. Shell splashes bracketed the small craft, yet the patrol boats were not retreating. They were closing the range. 2 boats attacked from the port side, driving straight through the destroyer screen. Machine gun fire from the lead destroyer tore through one boat's wooden hull, killing 1 gunner and wounding 2 others. The American commander kept his course steady, closing to 400 yards from the nearest transport. He fired all 4 torpedoes in a spread pattern, then turned hard to starboard and opened his throttles. The boat accelerated to 40 knots, spray flying, tracers from Japanese machine guns cutting the air behind him. 3 torpedoes struck the transport within 10 seconds of each other. The first hit forward, blowing a hole in the bow large enough to drive a truck through. The second struck amidships, detonating inside a cargo hold containing artillery ammunition. The resulting explosion broke the ship's back. The third torpedo hit the stern, destroying the propeller shaft and rudder. The transport began sinking bow first, going down in less than 4 minutes. There was no time to launch lifeboats. Soldiers crowded the rails and jumped into the ocean as the ship tilted vertical and slid beneath the surface. 2 more transports were sinking within minutes, struck by torpedoes from the other patrol boats. The Japanese convoy commander aboard his destroyer watched his convoy disintegrate. His destroyers had fired over 200 shells at the patrol boats. They had damaged several but sank none. The Americans had escaped into the darkness, leaving 3 transports on the ocean floor and 1,500 men swimming in the water among burning oil slicks and debris. The mathematical equation Japanese doctrine relied upon, that destroyer escorts could protect convoys from patrol boat attack, had been proven false. The Americans had found a way to win. The Imperial Japanese Navy's response to patrol boat effectiveness revealed how deeply the threat had penetrated their strategic thinking. In December 1943, Combined Fleet Headquarters issued new convoy escort requirements. Every transport convoy would now require a minimum of 4 destroyers, double the previous standard. Convoys would travel only on nights with minimal moonlight, reducing visibility for attackers, but also for the convoy's own navigation. Routes would be varied constantly, forcing patrol boats to search larger areas. These measures acknowledged that patrol boats were no longer a nuisance, but a strategic threat requiring major resource allocation. The resource cost was substantial. Every destroyer assigned to convoy escort was a destroyer unavailable for fleet operations, submarine hunting, or amphibious assault support. Japan's destroyer force was finite and shrinking. Combat losses, mechanical breakdowns, and insufficient shipyard capacity meant the number of operational destroyers decreased monthly through 1943 and 1944. Allocating 4 destroyers to escort a single convoy represented a significant percentage of available assets. Yet the alternative, sending convoys without adequate protection, meant losing the transports and their irreplaceable cargoes. Japanese naval architects proposed technical solutions. They designed new destroyer configurations, optimized for anti-patrol boat operations with additional searchlights, more machine guns, and improved fire control systems. They proposed building specialized escort vessels, smaller and cheaper than destroyers but adequate for protecting transports against patrol boats. These designs remained largely on paper. Japan's shipyards were overwhelmed with construction and repair of major warships, submarines, and merchant vessels. There was no spare capacity for specialized anti-patrol boat craft. The psychological impact on Japanese merchant marine officers was profound. Transport captains, who had sailed confidently through hostile waters, now requested postponements of critical supply runs. Some refused to sail at all without overwhelming escort forces that could not be provided. The Japanese convoy system, which had sustained garrisons across the Pacific despite American submarine attacks, began to fracture under the additional pressure of patrol boat operations. Supplies that should have reached forward bases never left port. Troops who needed reinforcement went without support. The cumulative effect was strategic, contributing to the isolation of Japanese positions throughout the Solomon Islands. American patrol boat crews faced their own costs. The casualty rate in the squadron through late 1943 and early 1944 was 38%. Nearly 4 in 10 men who served on the boats were killed or wounded. The wooden hulls that made the boats fast and maneuverable offered no protection against Japanese gunfire. A single hit from a destroyer's 5-inch shell would obliterate a patrol boat entirely. Even machine gun fire could be lethal, tearing through plywood and planking to strike crew members inside. The American commander survived the war, though his boat did not. On December 7, 1943, his boat was destroyed by Japanese air attack while moored at the forward base. He and most of his crew escaped, swimming ashore as their boat burned. He received command of another vessel and continued operations through mid-1944, when he was rotated back to the United States for reassignment. His official record credited him with participation in attacks that sank or damaged 18 Japanese vessels. He never spoke publicly about the men he had killed, the soldiers drowning in burning oil, the transport crews who went down with their ships. The statistics compiled by the Motor Torpedo Boat Squadron through 1944 documented their effectiveness in clinical terms. The squadron operated 42 boats over 20 months. They fired approximately 700 torpedoes. They were credited with sinking 43 Japanese vessels, including transports, destroyers, and small craft. They damaged dozens more. The cost was 14 patrol boats destroyed and 87 crew members killed. The exchange rate favored the Americans overwhelmingly. Each patrol boat cost approximately $200,000 to build, required a crew of 12 men, and could be replaced in weeks. Each Japanese transport cost millions of dollars, required crews of hundreds, and could not be replaced at all given Japan's shrinking industrial capacity and merchant marine. By mid-1944, Japanese convoy operations in the Solomon Islands had effectively ceased. The islands that Japan had fought so desperately to hold were isolated, their garrisons cut off from supplies and reinforcements. American forces bypassed many of these positions entirely, leaving them to wither without combat. The patrol boats had not achieved this outcome alone. Submarines, aircraft, and surface vessels all contributed to Japan's maritime defeat. Yet the psychological impact of patrol boat operations was disproportionate to their numbers. They had broken something fundamental, the assumption that Japan could sustain its far-flung empire through sea transport, even under hostile conditions. The success of the Motor Torpedo Boat Squadron in the Solomon Islands established tactical doctrine that spread throughout the Pacific theater. By early 1944, patrol boat squadrons were operating from forward bases in New Guinea, the Philippines, and throughout the Indonesian archipelago. Each squadron adapted the lessons learned in the Solomons: approach slowly at night, attack from multiple directions, fire at close range with torpedoes set shallow, and magnetic exploders disabled. The results were consistent. Japanese convoys suffered catastrophic losses wherever patrol boats operated. In the Philippines, a motor torpedo boat squadron conducted operations from bases established after MacArthur's forces retook portions of the islands in late 1944. The squadron operated in the confined waters between islands, where Japanese convoys attempted to move supplies from Manila to isolated garrisons. Between November 1944 and March 1945, this squadron sank 28 Japanese vessels, including transports, tankers, and escort craft. The Japanese responded by moving supplies almost exclusively during daylight hours when air cover was available. Yet this made convoys vulnerable to American aircraft. There was no solution that did not involve unacceptable risk. The Imperial Japanese Navy attempted to counter patrol boat operations through several means. They deployed their own small attack craft, including suicide boats that carried explosives and were meant to ram American vessels. These achieved minimal success. The suicide boats were slow, poorly constructed, and their crews were inadequately trained. American patrol boats simply avoided them or destroyed them with machine gun fire. Japan also experimented with radar-equipped patrol craft intended to detect patrol boats at night, yet radar technology, reliable enough for small craft installation, was beyond Japanese industrial capability at that stage of the war. More effective were Japanese floatplanes, particularly certain aircraft models that could operate from water bases near convoy routes and patrol during night hours when patrol boats were active. They achieved some success shooting down or damaging several patrol boats caught in the open. Yet Japan's air forces were stretched across the entire Pacific, and dedicating scarce aircraft to anti-patrol boat patrol meant fewer planes available for other critical missions. The resource allocation problem had no good answer. The most significant Japanese response was strategic rather than tactical. They reduced convoy operations throughout the Pacific, accepting that many positions would have to survive on stockpiled supplies rather than regular replenishment. This decision, forced partly by patrol boat effectiveness and partly by overwhelming American submarine and air superiority, sealed the fate of thousands of Japanese soldiers. Garrisons on bypassed islands starved. Disease killed more men than combat. Units that might have been reinforced and resupplied instead withered in isolation. Their defensive capabilities degraded to irrelevance. American industrial capacity ensured patrol boat operations could be sustained indefinitely. Manufacturing companies produced boats faster than combat could destroy them. By 1945, over 200 patrol boats were operating in the Pacific. They were equipped with improved radar, better communications equipment, and upgraded weapons. Some carried 40mm guns and rockets in addition to torpedoes and machine guns. The boats evolved from torpedo craft into multi-role platforms capable of engaging aircraft, supporting amphibious landings, and conducting reconnaissance. The American commander's career after patrol boat service reflected the Navy's recognition of small craft operations' importance. He was promoted and assigned to the Bureau of Ships in Washington, where he helped develop next-generation patrol craft designs. His input influenced post-war fast attack craft development, including patrol gunboat and fast patrol craft programs. He retired from the Navy in 1959 with elevated rank, having served 21 years. He died in 1973 at age 58. His obituary in naval publications mentioned his patrol boat service, but gave no details of specific operations or kills. The men who had served under him remembered differently, recalling a commander who had refused to send his boats on missions he would not lead himself. The patrol boat campaign in the Pacific represented a larger truth about modern industrial warfare that the Japanese High Command never fully grasped until defeat was inevitable. Warfare between industrialized nations was fundamentally economic. The side that could produce more weapons, more ships, more aircraft, and more ammunition, while sustaining higher loss rates, would win regardless of tactical brilliance or fighting spirit. Japan had entered the war with neither the industrial base nor the resource access necessary to compete with American production. Capacity over a sustained conflict. Consider the arithmetic of patrol boat operations versus Japanese transport capacity. Each patrol boat cost approximately $200,000 to construct in 1943. Each Japanese transport averaged 5,000 tons displacement and cost between $2 and $3 million to build, depending on specifications. The replacement time was even more skewed. American factories were producing patrol boats at a rate of 12 to 15 per month by mid-1943. Japanese shipyards, even operating at maximum capacity with no battle damage or resource constraints, could produce perhaps 2 or 3 transport ships per month. Every transport sunk by patrol boats represented an irreplaceable loss that degraded Japan's strategic mobility permanently. The manpower costs were similarly disproportionate. Patrol boat crews numbered 12 to 14 men. Japanese transport crews numbered between 150 and 300 men depending on ship size. When a patrol boat sank a transport, Japan lost not just the ship and cargo, but also trained merchant marine personnel who could not be quickly replaced. Japan began the war with a merchant marine of approximately 6 million tons of shipping. By 1945, losses to submarines, aircraft, and surface craft, including patrol boats, had reduced that to less than 2 million tons. The remaining ships were damaged, poorly maintained and operated by increasingly inexperienced crews as veteran sailors were killed. Psychological dimension of patrol boat effectiveness extended beyond Japanese naval forces to affect broader strategic decision-making. Japanese army commanders planning operations in the South Pacific and Philippines had to account for the reality that supplies and reinforcements might not arrive. This uncertainty affected tactical planning, forcing commanders to husband resources and avoid operations that depended on resupply. The cumulative effect was a Japanese military increasingly unable to conduct offensive operations, forced into defensive postures that played to American strengths in firepower and industrial support. American strategic planners recognized patrol boat effectiveness and incorporated small craft operations into broader campaign planning. During the Philippines' liberation, patrol boats supported amphibious landings by interdicting Japanese reinforcements and providing close fire support for troops ashore. During the Okinawa campaign, patrol boats patrolled against Japanese suicide boats and small craft attempting to attack the invasion fleet. The boats had evolved from experimental craft of dubious value in 1941 to essential components of naval operations by 1945. The technological lessons learned from patrol boat operations influenced post-war naval development worldwide. Fast attack craft armed with torpedoes or missiles became standard for nations that could not afford large surface fleets but needed coastal defense capability. The Soviet Union developed extensive fast attack craft forces in the 1950s and 60s, based partly on captured German designs, but incorporating lessons from Allied patrol boat operations. Israel, facing numerically superior Arab fleets, built its naval strategy around fast attack craft armed with missiles. The fundamental concept that small fast craft could threaten much larger vessels under the right conditions had been proven in the Pacific and became accepted naval doctrine. The individual human cost of patrol boat operations was rarely discussed in official histories. The boats were cramped, uncomfortable, and terrifying in combat. Crews lived with constant awareness that a single hit could kill everyone aboard instantly. There was no armor protection, no compartmentalization to contain damage. When a patrol boat was hit, it burned or exploded. Survivors ended up in the water, hoping rescue boats would find them before sharks did. The psychological strain of this type of warfare was intense. Many patrol boat veterans suffered what would now be recognized as post-traumatic stress disorder. Though the condition was barely understood in the 1940s, the nightmares, the flashbacks, the inability to sleep without seeing burning ships and drowning men, these symptoms persisted for decades after the war ended. Some veterans could never speak about their experiences. Others spoke obsessively, trying to process trauma that had no outlet in their time. Most fundamentally, they revealed the terrible human cost of warfare in the industrial age. Every technological advancement increased war's lethality. Every tactical innovation found new ways to kill more efficiently. The progression from ancient warfare, where combatants fought face-to-face with hand weapons, to modern warfare, where enemies die unseen at vast distances, might seem like moral progress. It is not. The distance that technology creates between killer and victim does not reduce the moral weight of killing. It merely makes it psychologically easier in the moment, then harder to process afterward. The patrol boat crews killed at close range. They saw their targets. This proximity to death was psychologically devastating. Yet perhaps it was more honest than high-altitude bombing where crews never saw the people they killed. Perhaps confronting the human cost of one's actions directly, however traumatic, was morally superior to the abstraction and distance that modern technology permits. There is no comfortable answer to this question. The Japanese captain who survived the war and spoke decades later about the moment he knew Japan would lose provides a poignant coda to this narrative. He recognized the fundamental imbalance in industrial capacity and tactical effectiveness that made Japanese defeat inevitable. He saw it in a single engagement, in the precision and coordination of the American attack, in the effectiveness of weapons that doctrine said should not work. His recognition was both intellectually honest and emotionally devastating. To know that the cause you are fighting for is doomed, that the sacrifices being made are ultimately futile, yet to continue fighting because duty requires it, represents a particular kind of tragedy. Many Japanese military personnel reached this conclusion at various points in the war, yet continued serving because their culture provided no alternative. They watched comrades die for a lost cause because honor demanded continued resistance, even when logic screamed for surrender. American forces experienced similar moral complexity from different perspectives. They knew they were winning. They knew their cause was just, or at least more just than their opponents. Yet knowing you fight for the winning side does not eliminate the moral weight of killing. Every Japanese soldier sent to the bottom of the ocean was still a human being with family and friends, hopes and dreams now extinguished. Victory did not absolve the victors of moral responsibility for the suffering they inflicted.